So we just so we have previously constructed two-valued logic, but in this class we are going to see we are going to construct three-valued logic and how to just relate them. Basically, we have how to relate propositional statements and their relations logically, and then how we can see the three-valued logic seems to appropriately address some of the conundrums or how can of quantum mechanics some of the Ellis or causal anomalies how they can be addressed in quantum mechanics or a three-valued logic and the implicate relationships which we can arrive at how it can address things generally, but in the sense the logically how we can quantum mechanically address some of the issues which are not addressed conventionally by two-values logic, where we can have on and off statements. So the thing is, before we are going to do the same thing, so we are going to construct the way we constructed the table for two-valued logic. If two, so again a construction of a table of three-valued logic, which will have interpretation through a three-valued logic. So we are going to three-valued logic, but since we had in the previous class taken analogy of two-valued logic and defined the table accordingly. So we'll just I'll not change much. So I'll just change the table only to just incorporate three-valued logic and see. So in the two-valued logic, you could have either truth statement or false statement. So how intermediate thing can be seen here also in this three-valued logic. So we can have we not only have truth and false, we also have intermediate. Indeterminate as a quantity, which is to be addressed, and we'll take how for example. So you can have so in the simplest sense, if we have A, this is truth, this is intermediate, this is false. So you can not only have negation, you can have negation may also be of different kinds. You have negation, you have complete negation, you have cyclic negation, and accordingly you can have the symbols can be attached to them. So in that sense, what is the value we are going to have? For example, this is a cyclical negation, this is a diametrical negation. Apart from this thing, we have something more to how we can construct things. You can have a complete negation. So one thing is that there is some similarity or analogy in how in commonsensical way understand all of these terms, but here when we impose a logic, we have a concrete, we assign them some particular meaning is assigned to those symbols. So truth, so it will be written as cyclical negation will be written as A, diametrical negation will be minus A, and complete negation means, so complete negation means if something is truth, the complete it's false will come out to be. So this is intermediate, this is false, this is truth, this is false, this is intermediate, this is truth, this is intermediate, this is truth, and truth will come out to be truth. Yes. Yes. Now, if we want to write a larger thing, maybe this will make it more clearer. this what I could say. Uh, so this so if we can construct once we have two volume logic, we normally have truth and false. Uh, but here we have truth, false, and indeterminate, and we are going to construct that at this table in a very general sense. In some cases, the two-valued logic can be seen as a limiting case of three-valued logic in some limited sense, in some particular sense. But the construction of three-valued logic in a very general sense, if we want to make a table out of it like this. For example, we are going to have 1, 2, 3, 4, 5, 6, 7, 8. So you can see. So you see, so we'll have A, B. So disjunction. One is conjunction, another is disjunction. Disjunction, you can note, related by this disjunction. Conjunction we write as A dot B like this. Standard implication means implication. You write it like A, this. Alternative implication. So an alternative implication means you can have alternatively. It doesn't follow directly. It can follow some other route. Sorry, it's A like this. Alternative implication is denoted by this quasi implication. So you can have quasi means in that sense it's a very weak statement. Write it this as compared to this. Standard equivalence. This is like this. Alternative equivalence. So it will be having 3 arrows, it will be having 4. So how we can construct, if we construct truth, truth in some general sense, then because there are 3-valued logic, we can have 3 variants of truth, 3 variants of indeterminate, and 3 variants of FFF. You can see, you can see here, you can see. So you can see. Now comes the table. So truth. So if B is also true, so B can come. So B can come in various variants. True, intermediate, false, true, intermediate, false, true, intermediate, indeterminate. Sorry, I'm talking of intermediate. No, it's indeterminate. So it's a bit. We can have. So you see. False, intermediate, false, false. Huh? You can have like this. So now what will happen? So disjunction. Disjunction means truth and truth. Disjunction of truth and truth, it will come truth back. Truth and what I should say, indeterminate, the truth will come back. You can see it the way you have conjunction, you have disjunction. In conjunction, you can just conjunct one thing with another thing. You can have analogy with sets, the way you have union, intersection, and other things. In that sense, you can have. So in the same way, truth and falsehood, it will come F. Truth and false. Sorry. For conjunction, it will come F. For disjunction, it will come truth. Will come back. Intermediate in truth, it will be I back. No, disjunction. Sorry. Truth will come back. Yes. Intermediate and indeterminate and indeterminate, it will come back. Indeterminate and falsehood, indeterminate will come back, because indeterminate is a larger statement. Falsehood and truth, what will come? Falsehood and truth will come back in disjunction. Falsehood and intermediate will come back. False will come back. Now in conjunction, it will be truth and intermediate will come out. In conjunction, it will come intermediate, because it's a lot indeterminate. Sorry, I'm again thing. Truth and falsehood in conjunction will come out to be false. Truth, when mixed with false, it becomes false. Intermediate with truth will come out to be truth. Intermediate with intermediate, it will come out to be I. I with F will come out to be conjunction, false. F with truth, it will also come false. False with this will come false. False with this will come false. So we can construct the tables. So the point is that these are two set of operations. So this on this vis-a-vis they are going to be intermediated by these, whether it's conjunction, standard implication, alternative implications. So we can construct this table. So further, maybe I'll write one of them. That will be we have done conjunction, then standard implication. So truth. So it will imply truth implies truth. Yes. Truth and intermediate. So it's indeterminate. So indeterminate is a larger thing. So we'll say it intermediate. Truth and falsehood. So when truth goes to false, the false comes out. Intermediate implies truth. Truth will come back. Intermediate, indeterminate and indeterminate, it will come indeterminate back. Indeterminate versus false, it should come false, should come back. Yes. Indeterminate falsehood. Intermediate, but it's intermediate, it's coming back. Falsehood versus truth. So false goes to true, true goes to false, it comes false, but false goes to true, it will come to be true. False goes to indeterminate. False goes to implies indeterminate, means truth will come back. False goes to false, it means this is an important statement. False goes to false. False implies false, but the statement can be true. It means that statement is true. So it's an interesting exercise to just maybe you can go for alternative implication, quasi implication as a weaker statement, standard equivalence, and alternative equivalence also as a weaker statement. So it will be a sort of pleasure or a slight joy, but joy with some sort of uncomfort. So to just see statements, their implications, and whatever their statements and their implications. Now, now what we are going to see is constructing these things. So you can say. So before we are going to see, so now, since we have done the truth table, so if we want to elaborate on this, how these statements mean, so disjunction and conjunction, even though they have the same spelling, or they might in the grammatical sense they might have origin the same sense, but their meanings come out to be different in that as we see in terms of elementary propositions. So disjunction is given by higher value, higher one truth, higher one truth of truth of the elementary propositions, and conjunction as a lower one of the truth. So conjunction, disjunction means higher. You will get something. You eliminate something, you will get something more purer as a statement as compared to the conjunction in that sense. So you can, in the same sense, you can say you can have a standard implication. Standard implication. So you can our standard implication, it may be of various kinds. In two-valued logic, you can have two or yes, but in truth, falsehood, and we had indeterminate. Even the standard implication had three-valued two. It might have what I should say three-valued two operation. Three-valued two operations. So you can have implication one or other, but it's in the sense of truth, falsehood, and intermediate, the combination of all the three made together. And the same can be for quasi implication. So in the sense, just like it's a higher value of truth, it's lower value. In the same way, you can have standard implication, maybe more truer as compared to quasi implication. It implies from this. And we can also say procedure of inference, which is represented by rule. If A is true and A implies B is true, then it means B is true. Now, Or symbolically, you can write A implies B, and if A is true, this means B is true. This means from this you can have this thing B is also true. And there is also, for example, in conjunction or disjunction, the some statements and or they sometimes in the, for example, if we consider and as an implication, this is owing to the fact that and says too much. And says too much. And if second line of this is inference holds, inference does not hold, it, the first line can be dropped in that sense. So, for in the same sense, for example, A implies A. It's always holds true. So now, but A implies B. It doesn't mean that B implies A. So if A implies B and B implies A, it means it's a symmetrical statement. So the weaker statement may be A implies B only. So in the reverse case, it's not that B shall always imply A in that sense. So if A implies B and B may not necessarily imply A, it's a non-symmetrical statement. Non-symmetrical statement. So here in that table we could see implied. So you can construct all sorts of implications from A to B, but from B to A. It may be implied for symmetrical statements. Can construct to those 3-value 2 logic, but it may not necessarily imply. You can have other statements also. Or if A is, or you can construct if A is equivalent to B. So this is another thing, implies. Now come equivalence. If A is equivalent to B, B is also equivalent to A. So in this we only need two tables in that sense. So you can also have, for example, as a binding force, we can have, if you want again see complete negation, cyclical negation, diametrical negation. So you can see negation also comes in different varieties. There's some, it's a more truer sense, less true, or so it has various variants. Negation has various variants. Diametrical negations, you can have equal force, strong binding force, denoted like this. Now conjunction, like this, disjunction, like this, standard implication, like this, alternative implication, like this, standard equivalence with 3 and alternative equivalence with 4, these things. So we have seen it here in that sense. So our truth values are so defined, only a statement having a truth value T can be asserted. Only T can be asserted. What does that mean? It means that So it means that only T can be asserted. So for example, so statement has a true value other than T. So assertion this states that it's indeterminate. That A is indeterminate. So other assertions are this A or A states it's false. So once we state a statement has value 2, its statement is a statement which is other than 2. So it cannot be the negation of the negation. It can be represented like that. If it's not true, if it's not false, it's something other than false, which is indeterminate. So in the same sense, we have talked yesterday also of tautologies. Tautologies normally they are agreed upon the linguistic rules. They are in a sense true statements or which cannot find contradictions or which do not find any loophole in that sense. Uh, so it has only T's in it. Tautologies have only truth values in it. And if a statement is contradictory, so it will have only F's in it. Now question is a statement which is very important. A statement is called synthetic if it has a true value, at least one true value, but the other part of the statement, one is truth, one part of the statement is true, the other part of the statement is other than true. So it may be indeterminate. So we can have various sort of combinations of these synthetic statements, and we can see how they will make statements. So for example, in two-valued logic, it's fine. The other two statements may be intermediate or truth or false. But if in three-valued logic, how do three-valued logic, how do synthetic statements maintenance their permutations and combinations via these, what I should say is how we define negation, conjunction, standard, or cyclical. So there will be a whole plethora of combinations and permutations via those, how we can conjunct them, disjunct them, or what I should say, negate them. In negation also we will have cyclical negation, absolute negation, equivalence, we'll have standard equivalence, alternative equivalence, standard implication, quasi implication. So we can have play with all sort of things in that thing. But the thing is that, so if for example, one part of the synthetic statement is true, but maybe other than true. It may be intermediate, or it is not contradictory. So if it has this synthetic statement has only, for example, the other part of the statement is only intermediates and F's in the column, then it's called a synthetic statement. statement. So the way, so if one part of the synthetic statement is true, other part is more than true, whatever that is, it may be not contradictory. So if it's intermediate or false, it's called asynthetic. So, but if it is both parts of the synthetic statement are true, that's a stronger version. So we can say they are called fully synthetic statements. Both parts of these synthetic statements are true. So, and if the other part of the synthetic statement is true or false, so it's true or it's true false, which you can say it's plainly defined. It's plain synthetic statements, synthetic statements. Now, the more interesting part may be, we can say the third, so in which the other part of one is true, the other part of is true or it's indeterminate. So if it is true or indeterminate, so in two-valued logic, if one is true, the other part of is true or false. You can have sometimes false. You can have synthetic statements in the two-valued logic. But if they are true and sometimes false, so this is called as semi-synthetic statement. So in the same sense, we can have, so you can construct, the idea of tautologies can also be constructed in some another way, is that you can have a tautology where you can say it's a cyclic tautology. Tautology means agreed upon statement which can be true. A truer statement can be constructed, for example, diametrical negation of contradiction is tautology. It's tautology. Means false of the, if a statement is false, we say it's false, it's true statement. So in the same, we can construct that diametrical negation of this statement is a tautology. So a synthetic statement cannot be made tautology by simply addition of negation. So this, think over it. So there can be another combinations. For example, we can say that contradictory and asynthetic statements are unassertable. Or on the other hand, tautologies and semi-synthetic statements are indisprovable. You cannot disprove them. So contradictory and asynthetic statements are unassertable. You cannot assert them. And tautologies and semi-synthetic statements are indisprovable. Unassertable means you cannot say they are true or false. You cannot. It's an open-ended statement. In that sense. So when a semi-synthetic statement is asserted, this assertion has some content, and it's not empty in case of a tautology. So we'll just continue our this thing, how we can further construct these tautologies, and how can basically our aim is how three-valued logic can just address. So we have constructed three-valued logic and these statements and these by these rules and that three-value logic. So now we have to see how quantum mechanical reality, some of the puzzles or anomalies which are there, which are neither addressed by both of these interpretations. One is the interpretation is corpuscular or wave interpretation, or in which one one interpretation is called, if I remember, if it's called, if I don't remember, restrictive interpretation, and the other interpretation is holistic interpretation. So we can see how three-value logic addresses some of those issues in the coming class.